All right, guys, today we're going to do segment addition postulate, okay? Segment addition postulate, also known as segment addition postulate, SAP. All the segment addition postulate says is, I can take a larger segment, AC, and show it as the sum of AB plus BC. This is why it's called a postulate. Remember, a postulate is something you accept as true, almost common sense. Obviously, the length from A to B plus the length from B to C is equal to the length of A to C. That's all the segment addition postulate says. It says I can take a larger segment and break it down as the sum of two smaller segments. So let's look at this example here. We need to solve for x in order to find RT. Well, this plus this equals that. So 2x plus 7 plus 28 is 4x. What allows us to do that? The segment addition postulate. We'll solve this out. This becomes 35. Bring this 2x over, 2x. X is 35 over 2. The problem asks us to find RT. Well, RT is equal to 4x. We're going to sub this in for x. 4 and the 2 cancel out. RT equals 7. Okay. All we're doing, segment addition postulate. The two smaller segments equal the larger segment. Let's try something a little bit more in-depth, more of the honors level that we're going to be looking at. Okay? So we need to find the length of these segments. In order to do that, we're going to have to do the segment addition postulate. This plus this equals the entire thing. So x squared plus 1 plus 5 minus x equals 20 minus 6x. What allows me to do that? Segment addition postulate. X squared minus x plus 6 is 20 minus 6x. Let's bring this 6x over. X squared plus 5x. Let's bring this 20 over. Minus 14 is 0. Okay? Whenever we have the x squared and the x's, we're going to be factoring. Multiply to give me 14, subtract to give me 5. 7 and 2, positive 5, negative 2. So therefore, x equals negative 7 or 2. We need to check all of these. All right, we need to check all of these. So let's check negative 7. If I plug negative 7 in here, right, AB will equal 49 plus 1, which is 50. Let's check it in here. BC will equal 5 minus negative 7. That's 12. AC, 20 minus 6 times negative 7 is 20 plus 42, which is 62. All of these values are positive. Just because x is negative does not mean it's not a possible solution. You have to plug it in. If it gives you a positive length, it is a possible solution. These are all possible solutions, and let's look. 50 plus 12 equals 62. So we have AB is 50, BC is 12, AC is 62. Next, let's check 2. If I plug a 2 in here, I get 4 plus 1 is 5. Let's plug a 2 in here. 5 minus 2 is 3. Let's plug a 2 in here. 20 minus 6 times 2 is 12. 8. 5 plus 3 is 8. So this is also an answer. 5, 3, 8. So we have two possible answers for x. 7 and 2. They both work. All right, since they both work, you need to put both of the possible answers. X is -7 or X is 2, and these are the possible values or lengths of those segments. Always check your answers. It could be one works, both works. It could be none work. Rarely do we have that, but it's possible. Okay? Recap, segment addition postulate just states that the sum of two smaller segments equals their larger segment. Or, as I like to put it, a large segment can be broken up as a sum of two smaller segments. A midpoint. We've already talked about midpoint, where it's the middle of a segment using the midpoint formula in coordinate geometry. Well, it's still in the middle, but now it bisects a segment, divides into two equal segments. So M being the midpoint means that AM is equal to MB, okay? AM is equal to MB. So if that's 3, that's 3. This one tick mark here shows congruence. So let's look here. M is the midpoint. That means that and that are the same. Right? That and that are the same. AB is 82. Therefore, MB, you just cut it in half, is 41. Here, again, you want to label everything. M is the midpoint, so those are congruent. AM is 17. That means AB must be double that, 34. Or you could say that's 17, and you add them. You can either double this or add them. You're going to get the same answer. And the reason we put, when you have to explain, is definition of a midpoint. What I want you to do now, there are a couple problems, practice problems, that'll be in your notes here and here. Complete those two after watching this video, and then we will go over them in class and do some classwork together.